Hello everybody. Today we will start to discuss problems from semifinal of US Olympiad USAPhO year 2007. Before that, I would like to introduce you what is this Olympia, how does it handle. So first tour, usually we have first round. Usually we have about 5,000 participants from all American schools, and they try to solve 25 problems and get as much score as possible. You have multiple choice from 5 different answers, and you need to choose correct one. If you want to go to next level, you need to solve as much problems as you can. Usually 18 problems, that's enough to go through, and 14, it's not enough. So if between 14 and 18, that's a choice. So it depends how strong is this Olympia problems and how strong are your other participants. So after the first round, there will be chosen 500 best one, and they will participate in the next round, semi-final or final. It depends from year. As you could see in previous videos, Rolex, we can see that there were only problems from mechanics, but in the second round we have other possibilities. We can have problems from mechanics, E&M, thermal, optics, and maybe some problems from modern physics like relativity, even maybe quantum mechanics, very simple. So that's the option for the second round. That was an introduction. Let's go for problems. Problem A1. A group of 12 resistors is arranged along the edges of a cube as shown in diagram on the right. The vertices of the cube are labeled from A to H, A, B, C, D, E, F, G, H. First problem A. There are resistors RAB equal RAC equal RAE equal 3 ohms. Resistors between CG, EF and BD, there are 8 ohms. And resistors CD, BF, EG by 12 ohms, and resistors DH, FH, GH, each 1 ohm. So we need to find what is the resistance between points A and H. As we can see, that's a complicated connection which cannot be solved just using regular parallel and series connection of elements. In that case, usually we need to use so-called Kirchhoff rules, 2 Kirchhoff rules, but that's very complicated usually. And in this kind of problem we can use symmetry. What does it mean, symmetry? Symmetry, it means that if we take from symmetry, we can say that some points have the same potential. We can just connect them, and because they have same potential, there will be no current through these 2 connected points. So it means that we didn't change anything. For same reason, if we disconnect something and as a result in two new points we have same potential, so we didn't change anything yet. So that's two tricks to solve problems with some symmetry. First, I can demonstrate you on a very simple case how does it work, this symmetry. Suppose that we have a cube with equal resistors. Same cube, but all resistors are equal, and we need to find if there are A, B, C, D, E, F, G, H. If we need to find what is resistance between this point and this point, A and H, we can see that points C, B, E, they are in a symmetry, so they have the same potential. So we can change it like this. If this is point A, there will be three resistors connected in the same point, which is C, E, B, and from other direction we have point H connected to 3 points symmetrical. That's F, D, G, F, D, D, G, and these 3 points and these 3 points, they are connected using this 6 equal resistors. So we can just draw these 6 resistors like this, and that will be equivalent picture for this one. And here this we can use a very easy parallel and series connection. So here we have 1/3 resistance. Here we have 1/6, and here again 1/3. So that's total 5/6 R0, where R0 we can choose resistance for one resistor. So this is how to use symmetry to solve problem for equivalent cube. In our case we have cube but with a different resistors, but with the same symmetry. It means that if we take point A and from this point we have 3 resistors, and the point C, B, E, in this picture they have symmetry, so it means that they have the same potential. We can connect them. That will be C, E, G. Same thing from point H. From point H we have 3 resistors going to 3 equivalent points, D, F, G. D, F, G. And now we have these 3 resistors, and these 3 resistors, they are very symmetrical, so they just connected in parallel with, between these 2 nodes. So we have 3 of them have resistance 8 and 3 of them have resistance 12. This is 3, this is 1. So it means that to solve this problem, for this part we have resistance 1 ohm. For this part we have resistance 1/3, and for this part we have 1/R equal 3 times over 8 plus 3 times over 12. So that will be 1 over 4 or 2 over 8. So that's 5 over 8. And the equivalent resistance R between these 2 points is 8 over 5. So finally we have 15 plus 24 plus 5 over 15, which is 44 over 15 ohm. So that's a final result, and this result is correct. Problem number, same problem A1, but other next question is question B. Now we have same setup, but instead of these 3 resistors with resistance 12 ohm, we put capacitors with the same capacitance 15 microfarad. So and we connected points A and H with a voltage V equal 12 volts. So we need to find what is the charge on each capacitor after this long period of time. So it means that now we have these capacitors fully charged, and there are no current through capacitor. Again, we can use equivalent connection as in previous case. This is point A, this is point H. Here we have each resistor 3 ohm and here 1 ohm, and here we have 3 capacitors here and 3 resistors with a resistance 8 ohm. So there are no current through capacitors when current is steady, and we have just equivalent connection, 3 parallel, 3 parallel, 3 parallel, and all of them in series. So first we can count what is equivalent resistance. So R just equal 1/3 plus 8 over 3 plus 1 over 3, which is 4 ohm. After that we can count what is current. Current equal 12 volts over 4 ohm, which is 3 ampere. If we have current 3 ampere, it means that due to symmetry we have through each of these 8 ohm resistors we have current 1 ampere. So it means that voltage between this and this point equal just 1 ampere multiplied by L8 ohm, which is 8 volts. And we have for each capacitor we have voltage on each capacitor is 8 volt. So it means that total charge Q on each capacitor equal capacitance multiplied by voltage, which is 15 microfarad multiplied by 8 volts, which is 120 microcoulomb. So that's correct answer.